Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to continue the discussion on LPWAN, which actually stands for Low Power Wide Area Network. Okay, for a start, I will emphasize the key difference between unlicensed band LPWAN versus licensed band LPWAN. Next, I will concentrate a little bit more on unlicensed band LPWAN. Under this unlicensed band LPWAN, we have LoRa, we have Sigfox, we also have this RPMA, which stands for Random Phase Multiple Access. Okay, because I have not done any discussion on this RPMA, so therefore this video, I will focus a little bit more on this new technology, RPMA. This will be the part 6 series discussion on LPWAN. So guys, if you're keen to know more about LPWAN, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on LPWAN. This is my email. If you have any question regards on this discussion, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask me through the comment. Okay, before I continue, I'd like to urge you guys to help this channel by like this video. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let's quickly do a quick overview of LPWAN. Okay, LPWAN is an emerging wireless communication network designed to facilitate long-range communication. Okay, long range, which in terms of kilometer, like 2 to 3 kilometer. Okay, basically they can only support low bit rate. Okay, low bit rate means that the throughput is actually very bad. They can carry very little amount of data. And because LPWAN is low power and hence the device can be battery operated. LPWAN can be divided into two main categories. Okay, first one will be unlicensed band LPWAN. Another one will be licensed band LPWAN. Whether they are unlicensed or licensed, actually based on the utilized frequency they actually use in order to establish communication. In short, what frequency they use, basically from there, we are able to classify whether they are unlicensed band or licensed band, which we are going to take a close look on this video. Okay, over here, you can see that these are the 6 so-called application, okay, region where we actually apply LPWAN. Okay, in fact, okay, LPWAN is utilized almost everywhere now in order to support this IoT. Okay, so definitely not restrict just to these 6 applications. Let's quickly focus on the unlicensed LPWAN. Okay, unlicensed band LPWAN actually operate in frequency band that are open for public use without the need for a spectrum license. Okay, I think we are all very familiar about Bluetooth. Okay, Bluetooth in fact is using 2.4 gigahertz. Okay, which means that we are always free to use this Bluetooth connectivity. Okay, basically we do not need to have a spectrum license in order to use Bluetooth. Okay, so basically, as the word utilized here, basically this unlicensed band is actually open for public to use. And in fact, you don't need any license in order to use this connectivity. So basically, this is what we call the unlicensed LPWAN. Okay, so these bands are governed by region regulation, okay, but typically include frequency like 433 megahertz. Okay, 433 megahertz is in fact widely used in China. 868 megahertz widely used in Europe, and in North America, they actually utilize this 915 megahertz. And last but not least, as this example, as I explained earlier on, this 2.4 gigahertz ISM band is used globally. Okay, so basically this is unlicensed band. From the frequency, okay, you basically know that they actually are unlicensed LPWAN. Okay, so there are some example about who are actually the unlicensed LPWAN. In short, the unlicensed LPWAN, we have LoRa, we also have Sigfox, and we also have this RPMA. Okay, so later on, I will explain a little bit more on this RPMA. But over here, let me quickly explain these two. Okay, so because these two are actually the first one and two runner for this unlicensed LPWAN. Okay, LoRa. Okay, basically this LO stands for long, this RA stands for range, and this is wide area network. Okay, so basically this is what is actually the name LoRa actually means, which is actually represent over here. Okay, so basically LoRa is a widely adopted unlicensed band LPWAN technology that use the church spectrum modulation technique to achieve long-range communication with low power consumption. Okay, so basically LoRa will be, in fact, at this moment, I think they are the most popular unlicensed LPWAN. Okay, they use a unique modulation technique, okay, which is church spectrum, okay, in order to achieve long range. They also find a technique how to reduce the power consumption. Sigfox is another popular unlicensed LPWAN technology that use UMB, okay, ultra narrow band modulation technique, okay, that is enable device to transmit small amount of data over super long distance, okay, with very low power consumption. Okay, let's quickly go through the advantages and disadvantages of unlicensed LPWAN. Okay, firstly, on the advantages, we have low cost. Okay, because we don't need to pay for the spectrum license. Okay, so therefore, because without the spectrum license, okay, the cost is in fact much lower. Okay, the license, okay, to operate in certain spectrum can be in terms of millions of dollars. So hence, because we don't need to pay anyone to use the spectrum, hence because of this, the cost will be very attractive. Okay, basically this actually reduce the overall cost of network deployment and also the operation. Another advantage will be the ease of deployment. Okay, so they are typically easier to set up and deploy, okay, due to the unlicensed nature of the spectrum. Just like Bluetooth, okay, we can easily set up, we can easily deploy, okay, because of unlicensed nature of the spectrum. When you actually utilize this unlicensed nature spectrum, okay, you must be easy for people to use. If not, no one want to establish communication using this unlicensed spectrum. Okay, coming to the disadvantage, okay, when you actually use unlicensed band, which means that you cannot prevent people to use the same frequency. And hence, because of this, you can imagine that definitely they will be vulnerable to have a lot of interference. Okay, because of this, okay, as you mentioned here, we are going to have a higher risk of interference from other devices and network operating in the same unlicensed band. Okay, because there's no straightforward regulation, okay, who can use this band. So therefore, you can imagine that the more devices that actually use this unlicensed band, the more interference we are going to subject with. Okay, we talk about this regulatory constraint. Okay, so basically subject to the region. Okay, basically the constraint, for example, there will be a duty cycle limitation. Okay, because this band is free for everyone to use. Okay, so the authority do not want everybody free to use this frequency, which means that they can utilize this frequency all the time. So therefore, they actually imply this duty cycle to limit the time that you are able to use this unlicensed band. And also that in some region, okay, for example, Europe, okay, we have these transmission power limits, okay, which means that you are not allowed to transmit power more than the so-called specified by the authority. And hence, because of this can be impact to the performance and in terms of the range of the communication. Now, I'd like to quickly go through the licensed LPWAN. Okay, for the licensed LPWAN, they actually operates in frequency band that require a spectrum license from the regulator. Okay, so basically, telco, for example, actually license some spectrum in order to establish, for example, LTE or 5G connectivity. So basically, they pay millions of dollars, okay, to the regulatory, okay, in order to use the licensed spectrum. Okay, so these bands are typically used by mobile network operator. Okay, for example, in Singapore, we have Singtel, M1, and StarHub. They basically pay some amount of money in order to use the spectrum. And because of this, they actually offer a more control and interference-free environment. Okay, because this frequency band is not free for everyone to use. Okay, only telco devices are actually allowed to utilize this spectrum. So hence, because of this, okay, you actually subject to have lesser interference. Okay, so under this licensed LPWAN, we have many NB-IoT and also LTE-M. Okay, NB-IoT, which actually stands for Narrowband Internet of Things. Okay, so basically it's a licensed LPWAN technology that is standardized by 3GPP. Okay, basically they operate in the licensed spectrum. Okay, for example, they utilize the 2G and also the 4G spectrum. Okay, basically this actually used to be used by, for example, 2G and 3 and 4G, and they basically use just a small little part of this 2G. 2G in fact is the whole part, and a very small part of this LTE. Okay, because they are using license band, so therefore they can offer secure, reliable, and efficient IoT connectivity. Okay, so another one will be LTE-M, which stands for long-term evolution for machine. Okay, so basically this mainly only use 4G. Okay, this is another 3GPP standardized technology that is actually leverage the existing LTE infrastructure to provide LPWAN connectivity within the licensed spectrum. In short, okay, basically this LTE-M can use part of the portion of 4G to piggyback your payload. Okay, so basically this is for the licensed LPWAN. Again, let's quickly go through the advantage and disadvantage of licensed LPWAN. Okay, so basically for licensed LPWAN, okay, they have some form of QoS, okay, which means that they can offer certain quality of service. Okay, because the licensed spectrum ensure a higher level of QoS, okay, with less interference and better reliability. Okay, so in short, in terms of security, okay, in terms of whether you are able to send the message over, okay, basically for licensed LPWAN, okay, you can be assured because they can actually guarantee some form of quality of service. Okay, so security is over here. So they have better security feature, okay, due to control and regulator access to the spectrum. Okay, you can also easily integrate with cellular networks. So basically they are actually utilize existing base station, okay, 2G or LTE base station. So therefore, this is what it means. You can leverage on existing cellular infrastructure, facilitate easier integration and border coverage. Coming to the disadvantage, okay, because you need to pay a lot of money on the license to use the spectrum. Okay, so this is one disadvantage. Another disadvantage will be the complexity, okay, because deployment and management can be more complex because you actually require to coordinate, okay, with the mobile network operator. Okay, so hence because of this, the deployment can be a little bit complex, okay, because you need to comply in the rules, okay, of cellular. Okay, so this will be the summarize of LPWAN for the unlicensed and licensed. Okay, because of the time constraint, I have mainly discussed all this, but I just want to quickly put into this so that you can take a quick look on the key difference between unlicensed band and licensed band LPWAN. Okay, before I continue, I'd like to urge you guys, okay, to help this channel by like this video. Okay, when more of you guys actually like this video will have a higher chances to reach out to a larger audience. So guys, help me by like the video now. If you have learned something from this video, okay, I urge you, please subscribe to this channel and also turn on your notification bell. Once again, I really appreciate your strong support. Help me. Okay, let's quickly go through the unlicensed LPWAN. Okay, let's start the discussion on LoRa. Okay, the most important unlicensed cellular technology are Sigfox and LoRa. Okay, so basically, I would say that Sigfox in recent year, okay, the adoption of using Sigfox start to decline. Okay, in fact, for LoRa, they start to increase. Okay, majority of the device that use Sigfox in the early days, they actually switch to LoRa. So therefore, I believe that LoRa actually command a higher market share as compared to Sigfox now. Okay, so LoRa is an LPWAN protocol and system architecture that is developed by the LoRa Alliance, okay, which provide low power and long range communication. Okay, the LoRa Alliance is an open, non-profit association with many global members from telecommunication companies. Okay, so LoRa is in fact now controlled by Semtech. Semtech actually define the physical layer of the system, okay, which is non-cellular modulation technology for LoRa. Okay, LoRa actually support adaptive data rate by balancing data rate and range. Okay, it use 6 spreading factor. Okay, from spread factor 7 to spread factor 12. So basically, over this range here, we actually have this 6 spread factor, which means that spread factor 7, spread factor 8, spread factor 9, spread factor 10, spread factor 11, and spread factor 12. Okay, where the higher the spread factor, they actually provide a longer range, which means that spread factor 12 provide a long range, but however, they can carry much more lesser data as compared to spread factor 7. In short, the higher the spread factor, the longer the range. However, the lesser the data they can actually carry. Okay, so basically this is for the lower spread factor. Okay, they can carry more data. However, they can only carry at a shorter range. Okay, LoRaWAN actually support both 250 kHz and 125 kHz. So over here you can see that, for example, for lower spread factor, okay, basically they will have a frequency, they have a bandwidth of 250 kHz. Okay, for a higher spread factor, for example, 12, they have a lesser bandwidth. For example, for this case, will be 125 kHz bandwidth. Okay, depend on the channel bandwidth and the spread factor. Okay, the throughput, okay, for LoRa is between 300 bits per second and 50 kilobits per second. Okay, LoRa actually define the protocol over the LoRa physical layer. Okay, it is a network architecture that operates in a non-licensed band. Okay, the most commonly used frequency band for LoRa are 433 MHz in Asia, 868 in Europe, and 915 in North America. In Singapore, we are actually using this 923 MHz. Okay, the adaptive data rate provided by LoRa technology enable the optimize of power consumption for different IoT application. In short, if you take a look on the playlist, okay, you see that LoRa actually has these different classes of device. Based on the different classes, actually they utilize different set of power. So in order to further so-called optimize the power, okay, you can always take a look on the playlist. Okay, so basically over here you will see that basically for LoRa, we still have the different classes in order to optimize the power. Okay, LoRa can provide coverage between 2 to 5 kilometers in urban environment. Okay, for me, I will always say that let's play safe is typically about 1 kilometer in urban, and typically is about maybe 5 kilometers in rural network. Okay, in North America deployment, LoRa can achieve a maximum data rate of around 100 kilobits per second, okay, in both uplink and downlink. Okay, the maximum data rate in Europe is usually lower than that in North America. Okay, because Europe, okay, the ISM band is actually very stringent. Okay, again, I have done this discussion. Okay, basically under the description, okay, you will realize that in Europe there are a lot of constraints, and because of this, the data rate for Europe typically will be lower than the America. Okay, another widely used unlicensed LPWAN will be Sigfox. Okay, so basically they will be, they are actually established in 2009, and they have deployed network in many countries, including Singapore. Okay, since 2012, they already deployed the network. Okay, Sigfox operate in the 868 or 902 MHz ISM frequency band, and they can provide a longer coverage as compared to LoRa. Okay, they claim that it's 30 to 50 kilometers. Okay, I would say around 10 kilometers should be very safe. Okay, and then 3 to 10 kilometers in urban, maybe around 2 kilometers in urban environment. Okay, the number of devices per access point can be as high as 1 million. Okay, I think this is too much exaggerate. Okay, I feel that typically one gateway can support, let's say, close to about a few thousand rather than 1 million. Okay, I don't think that any gateway can support up to 1 million devices. Okay, due to its use of an ultra narrow spectrum of 100 Hz. Okay, for Sigfox, the bandwidth is only 100 Hz. Okay, the uplink and downlink data rate are very low. Okay, because they use very little bandwidth, so therefore the amount of data they can carry is also very low. The maximum data rate of Sigfox is around 100 bits per second. Okay, although Sigfox provide bi-directional communication, okay, its downlink capacity is constrained. Okay, so basically for Sigfox, mainly uplink rather than downlink. Very few downlink. Majority you can provide uplink message, but very little of so-called capacity is actually assigned to the downlink. Okay, mobility is also another drawback for Sigfox. Okay, so basically this is why maybe Sigfox has a declined market share. Let's do a quick focus on this RPMA, which stands for Random Phase Multiple Access. Okay, so this RPMA is a wireless communication network used primarily in low power wide area network. So basically on LPWAN. Okay, they are actually developed by Ingenu. Okay, hopefully I didn't pronounce it wrongly. Okay, it is designed to enable connectivity for the Internet of Things device. Okay, so let's quickly go through the key aspect of RPMA. Random access. Okay, this RPMA actually use random phase shift in the transmit signal to allow multiple devices to share the same frequency spectrum. In short, you can imagine they basically control the phase, okay, in order for many devices to use the same frequency spectrum. Okay, so in short, they have a precise phase, okay, to indicate the message from which device, in short. So basically, this is what is on random phase multiple access. They use random phase shift, okay, to transmit the signal so as to support multiple devices to share the same frequency spectrum. Okay, this helps in minimize interference and enhance network capacity. Okay, multiple access. Okay, this refer to the ability of multiple devices to access the network simultaneously. Okay, RPMA actually achieve this through a combination of spectrum and random phase technique. Okay, so basically they use this spectrum. I have also done the discussion on spectrum, which can actually support multiple users. And again, they use this random phase to indicate the different device. So over here, you can imagine that the number of devices they can actually support actually is much larger. So in short, under this RPMA, they can actually support the most connected device, okay, which ensure that even with high device density, communication remains reliable. In short, under this unlicensed LPWAN, okay, this method RPMA can support the most connected device. Low power consumption, RPMA is actually optimized for low power consumption. Okay, they make it very suitable for battery powered IoT device. Then they need to function for extended period, okay, without frequent battery replacement. Next, okay, in terms of coverage, okay, RPMA actually provide extensive coverage. Okay, in fact, they offer much larger than traditional cellular network. Remember, this is traditional cellular network, which means 4G, 3G, okay, or 2G, but not NB-IoT. So basically, RPMA, they can actually provide a longer range as compared to the traditional cellular network. Okay, this is beneficial for IoT application in remote or hard to reach area. Okay, high capacity. Okay, so basically for this RPMA, okay, mainly, okay, basically they can support high capacity. The technology that support a large number of devices per network make it ideal for massive IoT deployment where many devices need to be connected and managed efficiency. Okay, the robust and reliability, RPMA make use of spectrum technology, okay, make it very robust against any interference and multipath fading, okay, where they are actually common challenge in wireless communication. Okay, this ensure a reliable connection even in challenging environment. Scalability, RPMA network can be easily scaled up or scaled down, in fact, okay, as the number of connected devices grow or decline, okay, without significantly degrade in performance. Okay, let's do a quick overall summarize of RPMA. Okay, basically they are very versatile, they are very efficient communication technology for IoT application. They offer a good balance of low power consumption, long range, high capacity, and reliable connectivity. Okay, so I realized I have made a mistake, so this should be RPMA. Okay, so with this, I'd like to end my discussion. Please help to like and subscribe. Once again, thank you so much for your time. Thank you, and I hope to see you guys soon. Bye for now.